All right, so the first type of bonding we're going to take a look at here is ionic bonding. And as the name is suggesting here, ionic bonding is going to involve things called ions. Okay. And what an ion is nothing more than something that has a charge. And that charge could be positive or it could be negative. Okay, so anything that has a charge on it is considered an ion. So how would an atom become an ion in the first place? Well, in order for an atom, which we know atoms are neutral, right? Number of protons equals the number of electrons. In order for an atom to become an ion, all right, we can't mess with the protons. Those are the things you have in the nucleus. What you can mess with is the number of electrons, right? So in order for an atom to become an ion, it must either lose or gain one or more electrons. And by doing that, you mess with that ratio of positive to negative, right? Because in an atom, remember, the number of positive charges, number of protons, equals the number of negative charges, the number of electrons, okay? That's why it's neutral. Its overall charge is 0. If we gain or lose electrons here, well, then we affect this balance. We're going to end up with something that has an overall charge on it. So that's the first thing to realize. Now, on our periodic table that we have, we're going to see a general trend that's going to be as follows. Now, we're going to see metals prefer to lose electrons, right? That's your first general thing that we need to be aware of. Now, remember, metals are on the left side of the periodic table. Okay, on the left and the middle, that's where metals are generally found. Now, when you lose electrons, but we're taking away negative charge. So whatever you end up then, if you take away negative charge, whatever you end up should have a positive charge. Right? So we end up forming positive ions. And we call these positive ions cations. That's how you pronounce that word, cation. So cations have positive charges. And we represent these charges as superscripts. Okay, we'll show you some examples here in a second. So for instance, we'll do it right now, actually. So for example, sodium, Na, the sodium atom, likes to lose in order to become more stable, remember? So it's going to lose one electron. When it does that, it forms Na with a charge of 1 plus. And this is then the sodium ion, right? Because we take away a negative charge from something that was neutral, we end up with something with an overall positive 1 charge. We take a look at calcium. So the calcium atom actually prefers to lose 2 electrons. And when it does that, guess what? We end up with something with a 2 positive charge. That's a calcium 2 plus, and that's called calcium ion. That's a cation. So metals are going to want to lose electrons. And remember now, the driving force for this is stability. So by losing electrons, if I look at sodium, for example, sodium is in group 1, so it's got that 1 valence electron. It wants to lose it. And by losing it, okay, now the next shell becomes the full shell, and that's going to have its 8 valence electrons. Similarly, calcium over here, calcium is in group 2, so sodium was right there. Calcium is here, it's in group 2, so it's got 1, 2. It wants to lose those 2 electrons to become more stable. Okay, that's for your metals. Now, if something is losing electrons, something else has to gain them. The electrons don't just disappear, they have to go somewhere. And where they go is to the other type of atoms on the table, which are the non-metals. And generally, we're going to see our nonmetals tend to gain electrons. And when they gain electrons, we're putting in more negative charges, right, into something that was originally neutral. So if you make the negative charge now more than the positive charge, then whatever you end up with is going to have an overall negative charge associated with it. So these are going to form negative ions, and we call negative ions anions, A-N-I-O-N-S. So for example, if we look at something like fluorine, so fluorine is in group 7. So it's got 1, 2, 3, 4, 5, 6, 7 valence electrons. So this is the fluorine atom, right? And just generally, if you think about, well, what would fluorine like or prefer to do? Do you think it prefers to lose all these 7? Or in order for it to be content or happy or stable, it would actually only need 1 more electron to complete its octet. So fluorine actually wants to gain 1 electron. So we can stick an additional electron in here. And by doing that now, we end up with not the fluorine atom anymore. Then we stuck 1 electron in. So whatever we end up with, the F is going to have a 1 minus charge on it. So that's the fluorine ion that we end up making. Similarly, if you look at something, let's do oxygen, for example, oxygen, the O atom is in group 6, so it's got 1, 2, 3, 4, 5, 6 valence electrons. Okay, do you think it's easier for oxygen to lose 6 or to gain 2 to be more stable? Well, it's a lot easier for it to gain 2. If we stick 2 electrons in here to make it happy, to make it content, to make it stable, then we've added 2 negative charges to this. So the O then is going to have a 2 minus charge. So that's the oxygen anion, the O2 minus. Okay, so that's the first thing to realize, is that your metals are going to want to lose electrons. By losing electrons, they form positive cations. Non-metals are going to want to gain electrons. By doing that, they form negative anions. And guess what can happen after? Well, once we form these positive and negative ions, well, as you probably know from experience, positive and negative attract each other. Opposite charges attract. And that attraction is the ionic bond. That is nothing more than something positive attracting something negative. That is ionic bonding. In order for the ions to form in the first place, right, something has to lose, something has to gain electrons. Why do they want to do that? To become more stable. Right? That's all that ionic bonding involves. It's attraction between a positive and a negative thing. So let's take a look at how we can predict the charges on these ions and how we can actually use the periodic table to help us. So we'll do a shortcut here, and then we'll probably go back in and review some examples. Okay, so the shortcut is for predicting the charges on, we'll call them monoatomic ions. So monoatomic meaning they're just single atoms. Okay, and what we're going to use to help us predict the charges is the periodic table. Okay, again, the periodic table is going to be very, very, very beneficial in a whole host of situations. This is just another example of it. So zoom in. Okay, we're going to use the periodic table to do this. So for metals, the charge on the metal ion is simply equal to the group number. And again, it's a positive value, okay? So that's simple enough. I can locate my element. If it's a metal, find the group number that it's in, whatever group number, that's the charge, and it's a positive charge, all right? So for instance, if you take a look at aluminum over here, right? Aluminum is in group 3A, and it's a metal. So aluminum group 3A. So then what we're saying is, according to this shortcut here, we have our symbol for the element aluminum. The charge is the group number, and the charge are going to go up with a superscript, and then it's positive. So 3 plus. And that's it. That's as easy as it comes in terms of determining the charges, right? If you look at something like barium, okay, if you find barium on the periodic table, it's in group 2A. So we have Ba, it's a metal. So the charge is going to be positive. And what's the group number? 2? 2 plus. That's it. Very, very easy. If we take a look at, so there's barium, by the way. We're here. We take a look at potassium, K. Potassium's in group 1A. All right, so if you look at potassium, excuse me, potassium, group 1A. So we have the symbol for potassium, K. The group number 1, it's a metal, so 1 plus. So you can quickly predict the charges on your metal ions. For non-metals, there's a similar thing that we can do. There's a little bit of math involved, but it's not super complicated. What we're going to do is we're going to take, to determine the charge, okay, the charge is simply equal to the group number, and then we're going to subtract 8 from it. All right, 8 there being the octet relevance. So for example, if we look at, what did we look at before? Oxygen. Okay, oxygen is in group 6. Okay, so that means then that the charge on the oxygen ion will be the group number 6 minus 8. And that gives minus 2 or 2 minus. So then when we write the oxygen ion, it will be O for the symbol and then 2 minus. There is a little bit of math involved, okay, but it's not nearly as complicated as any math that you've seen before. It's actually very simple. If we take a look at nitrogen, okay, so let's find nitrogen on the periodic table. Nitrogen is N, it's right here. So let's see, we have, that's group 5A. Okay, so nitrogen's in group 5. So then the charge would be the group number 5 minus 8. That gives 3 minus. So we have N, then 3 minus as your superscript. Okay, so again here, we're using the periodic table to help us predict the charges on these ions. Whether it's a metal ion, it's simply equal to the group number, positive charge. If it's a non-metal, the charge is the group number minus 8. Once we figure out these charges, then we can start figuring out, well, how many of these positives and negatives are going to combine with each other, because as we know, right, positives and negatives, opposite charges will attract. Okay, so but my point here is use the periodic table to quickly predict the charges on ions. Okay, it's very, very, very easy to do that as long as we can find the element on the table. Is it a metal? Is it a non-metal? All right, those are the first couple of questions you need to ask yourself. Once you figure out the charges, then comes the next part, which is putting the charges together, or putting the ions together in the right ratios.